So today we're going to be looking at some more Venn diagram questions. As it is a pretty important concept in probability. It is a foundational concept. So I thought I'd make another video on it where we're looking at some more questions and more detail to really solidify your guys' understanding. So if you look at the first question, it says which set of objects is represented by the Venn diagram below. So if you look at this, we've got sort of two sort of things to look at. We've got the color green and we've got the shape triangle, right? And over here in our images, we've got triangles and squares that are either green or they're red. So what this means is, again, I always like to look at this middle section first in Venn diagrams. I find that the easiest thing to look at. So this middle section of 2, what that means is that we have two sort of objects that are both green and are a triangle. Okay, so you have two objects that are green and triangle, nothing more, nothing less. So if we look at the options here, we can see that this one has two green triangles. So this is a potential correct answer there. This one has way too many green triangles, right? It has 5 of them. So this cannot be correct because we can only have 2 of them. This one also has 3 green triangles, so it can't be that option. And this one also has 2 green triangles. So we're looking at between option A and D here. The next sort of thing I'm going to look at here is that we've got this 2 on the outside. So what that means is that we've got 2 objects that are neither green nor are they a triangle. So in other words, we'd have to have 2 objects that are a red square. Okay, so over here we can see that we've got 4 objects that are a red square, so that's too much. And over here we've got 2 objects that are red square. So correct answer here would be D. Just to make sure that everything else is correct. So we've looked at this. Let's look at this part here. So what this 3 represents is that we've just got three objects here that are just green and not necessarily a triangle, right? So 3 objects that are green. So as you can see, that's what we've got here. We've got 3 squares that are green, but they're not a triangle. And then we should have 1 triangle that is not green. Okay, and we can see that here as well. So option D is the correct answer. So yeah, that's what we just found out. So question 2 now says that the Venn diagram below shows a set of numbers that have been sorted into prime numbers and even numbers. Now a number is chosen at random, and we have to find the probability that the number is prime and not even. Okay, so if you look at the solution for that one, we're looking at the probability that the number is prime and not even. Okay, so if we look at the Venn diagram, what sort of section are we looking at? For something that is prime and not even, we are looking at just this part here. It's not the overlapping part of the circle, but just this part of the circle here. This is just the prime section basically. Okay, so that's the sort of area that we're looking at. Okay, and you can see that in the solution here as well. So that we've got 10 total numbers. Okay, if you count up all the numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 3 of them are in this shaded area here. So therefore, the probability that the number is prime and not even is going to be 3 out of 10, which is option C here. Okay, so fairly simple question. Let's look at the next one now. We've got 50 people are asked whether they have been to France or Spain. 18 people have been to France, 23 people have been to Spain, and 6 people have been to both. Now from this information, we're trying to find the probability that a person chosen at random has not been to Spain or France. Okay, so again, we're going to drop the Venn diagram. Now, as I mentioned in my previous student before, when I'm creating a Venn diagram, I always look at this middle section first. That's what I try to find first and sort of work from that. And we're given that information here because we're given that 6 people have been to both France or Spain. So that's the first thing I would want. Create the Venn diagram and I would put in that 6 here. And then I'm going to sort of work backwards. Okay. Now we know that 18 people have been to France. So that means that in this entire circle here, that should add up to 18. So that's why we've got 12 here, because our 12 plus 6, that gives us our 18. We do that the same for the other circle because we know that 23 people have been to Spain. So this circle should add up to 23. So we've got 17 plus 6 gives us 23. Okay, now we also know that he's asked, well, 50 people have been asked in total. Okay, so if you add up 12 plus 6 plus 17, that gives us 35, right? Which means that we have 15 people outside here, which have neither been at Spain, nor have they been to France. Okay, so we also need to make sure we don't sort of forget that. That's a common mistake, that students will just make this and they'll forget about the total number of people that were asked. That's why they give us that information. So we know how many people are on the outside. Now, using that information, the probability that a person has not been to Spain or France is just 15 over the total number of people, just 50. If you simplify that, we get 3/10 as our answer. Okay, it's a bit more of a complex question in the sense that we've got to create the Venn diagram from scratch. But as I've said before, the easiest way to do it is figure out that part in the middle, and then you can work backwards from there, and it becomes more straightforward. And then looking at the next question, so here we've got a Venn diagram, and we've got a bit of algebra to do here. So it shows information about the number of students who study history and geography. So this just means that we've got 100 people in the set. So we've got 100 people in total. H represents history, G represents geography, and we have to work out the probability that a student chosen at random studies only history. Okay, so again, only history means that we're only looking at this. Oops, let's start up and let me just erase that. So we're looking at early history, so we're looking at the X+6 section only. So we're looking at just this part here. Yep, so not the overlap. Again, similar to that previous question that we did, we're just looking at this section here. Okay, so there's going to be a bit more work involved here because we're going to have to do some algebra. So let's have a look at how we do that. So what we have done here is that we know that we use this information here. We know that the total number of people that have been surveyed, or the total number of students that have been surveyed, is equal to 100. So that means that every element in this Venn diagram here, if we add them all up, it should give us 100, which is what we've done here. Okay, now we do some algebra here, and once we get that, we sort of get an algebraic expression here. So we get x squared minus x plus 70 needs to equal to 100. Bring the 100 over to the other side, and we've got a nice little quadratic sort of equation here, where we've got x squared minus x minus 30 is equal to 0. And using our quadratic skills, we sort of factorize that into x minus 6 bracket x plus 5 is equal to 0. That means that x can equal 6 or x can equal negative 5. Sorry, my highlighting is all over the place here. Let me just remove all these annotations. It's probably better. Right, so we know that x is equal to either 6 or x is equal to negative 5 here. Okay. Now we can't really have two solutions because then we're going to have two different, or we can have two solutions. But in this instance, it's only asking us for one solution because we are assuming that x cannot be negative. Now, in reality, there's no reason why x can't be negative, as long as this overall expression that it gives us would be positive. So, like, for example, let's say if x was negative 8, negative 8 plus 6 would give us negative 2. Okay? Now, we can't have negative 2 here, right? Because that doesn't make sense. You can't have negative 2 students that only study history. Okay, so in that case, it wouldn't make sense. But over here, x is negative 5. So if you have negative 5 plus 6, you would get 1. Which is perfectly fine. We could have one student that only studies history. Even in this instance here, it says if you have negative 5 times negative 5 minus 2, we're going to get negative 5 times negative 7, which is 35. Right? That gives us 35 again, which is a positive number. So there's no problem with that. But since we have to assume that x cannot be negative, we just stick with this other solution here of x is equal to 6, and then subbing that in. If x is equal to 6, that means that the number of people that study history is 12, which we've seen here. And so let me erase that. Yep, so x equals 6, that means that the number of people who study history is 6 plus 6, which is 12, over the total number of students, which is 100, and that gives us our final solution of 3/25. It's a bit more of a trickier question in the sense that we have to use some algebraic skills there, but again, that fundamental process of finding out the probability and working it out that way, that sort of remains the same.